Hello, 6th grade. Today, lesson 78, graphing inequalities. The key here is an inequality, something like greater than, less than or equal to, greater than or equal to. Those are inequalities, and they have special rules that deal with finding how to communicate that information, which is really what you're doing here. Communicating information that is infinite in nature, as we will see. Now, we can graph an equality very simply with just a point. If we ask, where on the number line is x equal to 2, there's one place on that number line where x equals 2, and that's a big fat dot right there on the number line where x is 2. There's just 2 here, right? And so we put a big dot there. We'll call that a closed circle. All right, it's a circle that's all shaded in, and that's it, because when x equals 2, it equals 2 and nothing else, right? Very simple. It is one thing, just a point on the number line, all right? An inequality, however, has an infinite number of possible solutions, of possible things, possible values for x that are correct. If we talk about x is greater than or equal to 2, how many numbers are there greater than or equal to 2? Yeah, a lot. And don't forget decimals and fractions and all that stuff too, right? And as soon as you name the last number greater than 2, then I can add one more to it. I mean, it never stops. And so there are an awful lot of numbers greater than or equal to 2, and that's not even counting all fractions and decimals. So the question is, how do you show an infinite number of things on a single piece of paper? And that's the idea of graphing an inequality. Okay? So how do we show them all? We use a number line. We've always had number lines with arrows at the ends that mean they extend in both directions forever. And so to start graphing an inequality, you start with a number line. All right? And we start with, we need a 0, we need arrows at both ends, and then we need the number that we're interested in, 2, right here. I could put a 3, 4, and a 1 here, but I don't have to. The important things are the number, 0, and the arrows. Those are common to all graphs of inequalities. And we say that x is greater than or equal to 2. Well, if it's equal to 2, we could put a big, fat, closed circle on the 2, and we'd be correct, because this says greater than or equal to 2. But now we got to show the greater than part as well. Well, what is greater than 2? I mean, 3 is, so is 4, 5, 6, 7. All the numbers in this direction are going to be greater than 2. But if I go the other direction from this dot, I got 1. That's not greater than 2. 0, that's negatives are not greater than 2. So I do not want to go that way, but everything this way is greater than 2. And we show that by what's called shading. And that's just simply on the number line, from the number you're interested in, I'm just going to make a squiggly shade with an arrow symbol that goes on, that shows that shading goes on forever. That way I don't have to go on forever that way. All right? And that's the answer. I have just graphed everything in the universe that is greater than or equal to 2 by using a closed circle on 2 and shading all the direction that is greater than 2. All right? So how about a number, how about a thing, an inequality that says x is greater than 2? That's different, right? Because 2 is not greater than 2. So what's the next number greater than 2? 2.1. What about 2.01? What about 2.00001? No. See, we get around that difficulty, all right, by saying 2 doesn't work, but the next number greater than 2 does work by using not a closed circle, but what we call an open circle on the number that we're interested in. We draw an open circle around that number when we are not equal to that number, but greater than or less than that number. And then I want all the numbers that are more than 2. Again, numbers that are more than 2 are all going to be to the left or to the right here, all right? And so from this open circle, I'm going to shade and draw a nice big arrow there on the number line. So the difference here is that when there is not an equal to sign, I use an open circle. When there is one of these equal to signs, I use a closed circle. All right, so there are some patterns that we can use to make graphing inequalities easier for us. And that is very simply that if the inequality symbol has this equal to sign, then it's going to be a closed circle. If the inequality is simply greater than or less than, we use an open circle on the number. So that's the first thing. Do we use an open circle or a closed circle? And the second thing you have to decide is which direction to shade. Do you shade to the right or do you shade to the left? And it turns out there's a nice little pattern for that as well. Because when the variable is on the left side of the inequality, all right, something like x is less than 1. Here the variable we say is on the left side and the number is on the right side. And this is the way you're typically going to see these inequalities, which is good because that gives us a way to know which direction to shade. Because when the variable is on the left side of the inequality, then the direction of the symbol is the direction you shade. In other words, if the symbol is pointing in this direction, greater than, we are going to shade in that direction. If it's greater than this way, we're going to shade in the direction that it's pointing. If the symbol is less than, we're going to shade in the opposite direction. Whichever direction the symbol is pointing, that's the direction we shade. And that's true when the variable's on the left side. So, with those two things in mind, we have to consider when we graph inequalities, we simply ask ourselves, okay, do I do an open or a closed circle? And then the direction of the shading. Piece of cake. Let's look at some examples here. Graph. X is less than minus 1. All right? Start off immediately with the number line, a 0 and a minus 1. You don't need to put in all the numbers. But those are the important ones. The number we're interested in, a 0, which is important in a number line, divides things in half. All right? So that's how we start. And now we have to ask ourselves, do we do an open circle on minus 1 or a closed circle? You're right, it's an open circle because it is not equal to minus 1. All right? We want what's less than minus 1, but not equal to minus 1. So that is the open circle. And then which direction do we shade? Do we shade to the right or to the left? Well, the inequality is pointing to the left, so I'm going to shade to the left. And in fact, you can never get these wrong because the number one mistake people make is they shade the wrong direction. So take 5 seconds to pick any number that you have shaded on the number line and see if it works. If I shade this way, I'll hit minus 10. So is it true that minus 10 is less than minus 1? It is. All right. So, what about this one? All right. X is greater than or equal to 0. In this case, I got the number line, I got 0, and got a parent out there. It needs to come in. Front door, front door. Sorry, take a break. Yep. So now, first thing I gotta do, out the front door. Yes, you just came around. So, X is everything that is equal to or more than 0. So I ask myself, open circle or closed circle? Well, it's got a line under it, so that's a closed circle. Oh, yeah, it's a closed circle because it's got that equal to line and it's pointing in that direction. So we go that way. Very simple. All right, how about this? X is greater than or equal to minus 5. So, draw number line, 0, minus 5. Always a good way to start. And so I've got open circle or closed circle. Well, it's got the little line under it, which means closed circle on the number we're interested in. And it's pointing in that direction. And so I shade in that way. And I ask myself, I pick a number in the shaded thing like 0. Is it true that 0 is greater than or equal to -5? Yeah, it's better to have no money than it is to owe $5, right? So the graph of that inequality looks like that. How about this one? X is less than or equal to 6. Do that on your own right now. Stop the tape and we'll see if you get it right. Yeah, did you do it right? Equal to, so closed circle, shading to the left. Check your work. 0 should be less than 6. It is. It works. All right. We can translate words also onto mathematics. Here it's the instructions are graph everything more than 1. You got to think everything more than 1. All right. Is 1 more than 1? Well, don't think so. 1 is the same as 1, so 0, 1. Everything more than 1, so I'm going to use an open circle on 1, and I'm going to shade the direction of numbers that are more than 1, like 2, 3, 4, 5, and so it looks like that. How about something like graph everything smaller or the same as -4? All right, draw a number line, 0, -4. Everything smaller or the same as. So in this case, -4 works, so I'm going to use the closed circle on -4. And I want smaller than, so anything smaller is going to be to the left and shade in that direction. And there we have it. All right. So that's what you're going to be asked to do in lesson 78, A to D. Draw those number lines. Pay attention to open or closed circle, and certainly pay attention to the direction when you do A to D and 9 to 15.